Welcome to the lesson on gloves. In this lesson, we will focus on how gloves can offer crucial hand protection from electrical and chemical hazards, enabling secure handling of components and ensuring a safe and productive work environment. Let us now look at our lesson objectives. By the end of this lesson, you will be able to identify the purpose and voltage rating of Class 0 gloves. Next, you will be able to explain the procedures for wearing both rubber lineman's gloves and leather protectors. Following that, you will be able to describe the steps involved while using gloves. Later, you will be able to explain the importance of glove testing, certification dates, and recertification intervals. Finally, you will be able to describe the best practices for glove storage, sizing, and the use of glove powder. Class 0 gloves are essential to your protective equipment when working with high-voltage electrical systems. These gloves are designed and rated to protect you from electrical shock hazards. The rating Class 0 indicates that these gloves can withstand a maximum voltage of 1000 volts AC or 1500 volts DC. This means that when you wear Class 0 gloves, you have a reliable barrier between your hands and potentially lethal electrical currents. These gloves are rigorously tested and certified to meet industry safety standards, ensuring they provide the protection necessary when working on high-voltage systems. Class 0 gloves are a recommendation by most automotive manufacturers. This recommendation reflects the industry's commitment to safety and acknowledges the hazards of high-voltage systems in modern vehicles. High-voltage batteries, such as those in BEVs, can pose significant electrical risks. These risks include electric shock, arc flashes, and other potential hazards. Wearing the appropriate PPE, including Class 0 gloves, is non-negotiable when working on high-voltage batteries. Even a momentary lapse in PPE usage can lead to severe injuries. Your safety and the safety of your colleagues depend on your commitment to wearing proper PPE consistently. One of the most critical safety aspects is protection against electrical shock hazards. Class 0 rated rubber lineman's gloves are your first defense in this regard. This protection is essential when working with high-voltage systems. While Class 0 rated rubber lineman's gloves are designed to offer superior electrical protection, they are not immune to physical damage, such as tears or punctures. This is where the practice of wearing leather over lineman's gloves comes into play. Leather gloves serve as an additional layer of protection for your rubber lineman's gloves. Both leather and lineman's gloves must be worn together. They act as a barrier against physical hazards that can damage the rubber gloves. While working in an automotive repair environment, you may encounter sharp edges, abrasive surfaces, or objects that could tear or puncture your rubber gloves. Leather gloves act as a buffer, helping to prevent such damage. By adding this extra layer of protection with leather gloves, you extend the lifespan of your rubber gloves and ensure their integrity. This is crucial because damaged rubber gloves can compromise their effectiveness in providing electrical protection. As we proceed through this lesson, we will look at the detailed steps involved while using gloves. Step 1. One critical aspect of wearing rubber gloves and leather protectors is the relationship between their cuffs. The cuff of your rubber gloves should extend at least half an inch beyond the cuff of your leather protector. This small detail is essential in ensuring your safety while working on high-voltage electrical systems. The cuff of rubber gloves is designed to provide electrical insulation. When it extends beyond the leather protector's cuff, it ensures no direct contact between your skin and any potentially energized or hazardous components. This is crucial in preventing electrical shock hazards. The extended cuff of rubber gloves also offers protection against physical damage. For example, you may encounter sharp objects or abrasive surfaces. The overlap between the rubber gloves and leather protectors is a barrier, reducing the risk of tears or punctures in your rubber gloves. Maintaining the proper cuff extension helps keep your rubber gloves securely in place. If the cuff of the rubber gloves is tucked inside the leather protector, it may become dislodged during work, exposing you to potential hazards. A proper cuff extension ensures that your gloves stay in position, providing continuous protection. Remember, both leather and lineman's gloves must be worn together. Step 2. Properly fitted gloves are essential to your overall safety and well-being while on the job. You will need a soft tape measure to determine the correct glove size, often called a tailor's or measuring tape. This type of tape is flexible and allows for precise measurements. Begin by wrapping the soft tape measure around the palm of your hand. Ensure that the tape measure is snug but not overly tight. It should follow the natural contours of your palm. Take note of the measurement you obtain. For example, if the tape measure reads 9 inches when wrapped around your palm, you have measured a palm circumference of 9 inches. Once you have your palm circumference measurement, you can easily correlate it to the appropriate glove size. Typically, glove sizes are indicated numerically and correspond to the measured palm circumference in inches. In other words, if your palm measures 9 inches, you would select gloves with a size of 9. This simple yet crucial process ensures that your gloves fit correctly, providing the safety, protection, and comfort necessary for your tasks. Step 3. The rating of a glove denotes its suitability for specific electrical conditions and voltage levels. This information is essential to ensure you use the suitable gloves for the task. For example, in environments with electrical hazards, the glove rating indicates the maximum voltage level the gloves are designed to withstand safely. This knowledge is critical in choosing gloves that protect against electrical shock. Stamping the date of the last test on the glove cuff is a visual indicator of when the gloves were last inspected and certified for use. This date allows you to track the glove's maintenance schedule in compliance with safety regulations. Marking the glove cuff with the test date also helps enhance accountability and workplace safety. It allows supervisors and safety officers to assess whether gloves follow safety standards and regulations quickly. Having a visible date on the gloves makes it clear when the next inspection is due, reducing the risk of using gloves past their testing date. Knowing the glove rating and the date of the last test on the glove cuff assures that you are using gloves that have been rigorously tested and are up to date with safety standards. This assurance is essential when working with high-voltage systems, where the consequences of inadequate protection can be severe. After using electrical gloves for the first time, and then at intervals of every 6 months, the gloves must be recertified or replaced. If the first date of usage is unknown, the gloves must be recertified or replaced before being used. Step 4. The fingertips of gloves are often the most vulnerable areas because they are in direct contact with various surfaces and materials during automotive service tasks. By starting with a visual inspection of the glove fingertips, you focus on the areas most prone to wear and tear. This inspection allows you to detect cuts, punctures, or other forms of damage early on before they compromise the overall integrity of the glove. A damaged fingertip could expose you to electrical hazards, so thorough visual inspections are crucial. Any visible damage, even minor cuts, can compromise the insulation properties of the gloves and expose you to the risk of electrical shock. You may work with various fluids and materials that may be harmful or hazardous. Damaged fingertips and gloves can allow contaminants to penetrate the glove, potentially leading to skin exposure and chemical contamination. Inspecting the fingertips for any cuts or damage can prevent such contamination and ensure your safety. Detecting and addressing fingertip damage early can also extend the overall lifespan of your gloves. Step 5. Visual inspection is a straightforward yet highly effective way to identify damage to your gloves. Damage to gloves can result from exposure to various substances and factors. You may come into contact with petroleum-based substances like motor oil, gasoline, and grease. These substances can weaken and degrade glove materials over time, leading to reduced protection and increased vulnerability. Cleaning agents and detergents used in automotive service or maintenance tasks may contain chemicals that can harm glove materials. Prolonged exposure to such substances can cause deterioration and compromise the glove's effectiveness. Even hand soaps, particularly those with harsh chemicals, can contribute to glove damage if they come into contact with the gloves regularly. Over time, these chemicals can break down the glove's structure and reduce its protective properties. While talcum powders are sometimes used to ease the donning of gloves, excessive use can accumulate talc inside the gloves. This can reduce the glove's ability to provide a secure barrier, making them more susceptible to damage and contamination. Step 6. Begin by manually inflating the gloves with air. You can do this by inserting your hand into the glove and blowing air into it. Ensure that the glove is fully inflated but not overinflated to avoid damage. Begin the inspection at the cuff, the glove part near your wrist. Ensure the cuff is securely sealed and there are no visible leaks or damage in this area. Gradually, roll the glove from the cuff toward the fingers while trapping the air inside. As you roll up the glove, closely watch and listen for any signs of deflation. Even a tiny pinhole leak will cause air to escape, and you should be able to hear a hissing sound or feel the glove deflating. If you observe or hear any signs of deflation during the inspection, this indicates a pinhole leak in the glove. It is crucial to discard the glove immediately if a leak is detected. Dispose of the damaged glove following proper safety protocols for contaminated or damaged PPE. Step 7. As technicians, you may encounter petroleum-based substances during service, maintenance, or repair tasks, such as when working with lubricants, greases, or hydraulic fluids used in certain components. In this step, we will look at why petroleum on the leather protector's surfaces can be problematic for the rubber glove underneath. The rubber glove is a barrier to protect your hands from chemical exposure. However, leather protectors are often used as an additional layer over the rubber glove. These leather protectors are made from leather, and they serve several purposes. They can protect the rubber glove from physical damage, such as cuts and abrasions, and provide thermal protection in high-temperature environments. The issue arises when petroleum or oil-based substances are on the surfaces of the leather protectors. Petroleum-based substances can break down the rubber material in the inner glove. This breakdown can weaken the rubber glove's integrity, making it more susceptible to chemical penetration and reducing its effectiveness in protecting your hands. In essence, the petroleum can compromise the barrier created by the rubber glove, potentially exposing your skin to harmful chemicals. To ensure your safety when using a layered glove system, it is essential to inspect both the leather protectors and the rubber gloves for any signs of contamination or damage before use. If you notice any petroleum or other harmful substances on the leather protectors, it is crucial to clean and replace them to maintain your protective gear and keep yourself safe from chemical exposure. Step 8. Glove powder serves a valuable purpose primarily by absorbing moisture and minimizing friction. This powder is applied to the interior of gloves for several important reasons. One of the critical functions of glove powder is to absorb moisture, such as sweat, that accumulates inside the glove during extended use. Moisture can make gloves uncomfortable and reduce their effectiveness. The powder helps keep the wearer's hands dry and comfortable by absorbing this moisture. Friction between the skin and the glove can lead to discomfort, irritation, and even blisters, especially during prolonged wear. Glove powder acts as a lubricant, reducing friction and allowing the gloves to slide on and off more easily. This can make it more comfortable to wear gloves for extended periods. Applying glove powder to the interior of gloves makes them easier to put on. This is particularly important when gloves must be quickly and effortlessly donned, such as when dealing with hazardous materials. It ensures that the gloves can be worn without unnecessary delay. In certain environments, gloves can become sticky due to humidity or chemical exposure. Glove powder helps prevent this stickiness, ensuring the gloves maintain their usability and effectiveness. Step 9. Begin by putting on the high-voltage gloves designed to protect you from electrical hazards. Ensure they fit snugly but comfortably on your hands. You should also wear leather protectors over the high-voltage gloves. These leather protectors safeguard the high-voltage gloves from physical damage and punctures. After wearing the high-voltage gloves, secure the straps on the back of the leather protectors to ensure they fit securely. This step is crucial as it ensures that both layers of protection work effectively together. Step 10. The requirement for technicians to wear high-voltage gloves and leather protectors when working around high-voltage areas of a BEV is an essential safety measure. It offers a robust defense against electric shock, electrical hazards, and physical damage, enabling technicians to perform their tasks while prioritizing their personal safety confidently. Adopting these safety standards is non-negotiable in BEV maintenance and ensures that technicians can work effectively and safely in high-voltage environments. Step 11. When your high-voltage gloves and leather protectors are not in use, it is essential to store them properly to maintain their effectiveness and prolong their lifespan. Place your high-voltage gloves and leather protectors in a canvas storage bag designed for this purpose. A canvas bag protects from dust, moisture, and contaminants while allowing for some airflow. Pay attention to the ventilation hole located at the bottom of the bag. This hole is there for a specific reason. It allows air to circulate inside the bag. Proper ventilation helps prevent moisture buildup, which can harm the integrity of the gloves and protectors. By storing your high-voltage gloves and leather protectors in a canvas bag with ventilation, you ensure they remain clean, dry, well-maintained, and ready for safe use when needed. Step 12. When placing rubber gloves in the canvas bag, avoid folding them. Folding can subject the material to mechanical stress, potentially leading to permanent failure. Instead, gently roll or lay the gloves flat in the bag. To prevent unnecessary strain on the gloves, lay them flat in the bag, ensuring they are not creased or folded. This helps preserve the structural integrity of the gloves and ensures they are ready for use when needed. We will now look at some of the best practices for glove maintenance. Before using gloves, it is important to inspect them every time thoroughly. Look for any signs of damage or wear to ensure they are safe for use. When it is time to replace gloves, make sure to follow the guidance provided by the manufacturer. This guidance will tell you when gloves are no longer safe or practical. Before using electrical gloves for the first time, and then at intervals of every 6 months thereafter, conducting electrical tests on the gloves is crucial. This testing helps ensure that the gloves provide the necessary protection when working with electricity. Let us look at our lesson summary on gloves. Class 0 gloves protect technicians from electric shocks up to 1000 volts AC or 1500 volts DC. They are standard PPE for working on high-voltage BEV systems. Rubber gloves must always be worn with leather protectors, with rubber glove cuffs extending at least 1/2 inch beyond the leather cuffs to maintain insulation and prevent exposure. Glove inspections should include visual checks, especially fingertips, inflation tests for leaks, and ensuring gloves are not damaged by contaminants like petroleum or harsh cleaners. Gloves must be tested every 6 months or replaced if their usage date is unknown, and test dates should be clearly marked on the glove cuffs. Proper glove fit and sizing ensure safety and comfort, while glove powder reduces moisture and friction during prolonged wear. Storage in a ventilated canvas bag without folding helps preserve glove integrity and keeps them ready for safe use. Thank you.